Hey folks, now we're gonna take a look at a special type of function called quadratic functions, and there are going to be two different ways people tend to look at quadratic functions. I'm going to break it into to two big areas. So the first big area is going to revolve around this definition. This is like the real deal definition of a quadratic function. A quadratic function has the form f of x equals ax squared plus bx plus c, where the a, the b, the c, those are just real numbers, and well, a can be any real number except a can't be 0, because if a were 0, that term would be gone and it's no longer quadratic. It's then going to be called a linear function. So that's the real deal definition of a quadratic function, and like I said, there are going to be two different ways to look at it. But let's really focus on this way right now. First and foremost, I want you to know that the graph of a quadratic function, any quadratic function you see, the graph is called a parabola. So I'd like you to know the graph is called a parabola. And to break this down even further, if over here in your f of x equals ax squared plus bx plus c, if a, remember a is a real number, if a is greater than 0, then your parabola will have that shape. It's like a happy parabola. If a is a negative number, if a is less than 0, then the parabola will have that shape. I call it a sad parabola. So, see, we're building up right now. Quadratic function has the form ax squared plus bx plus c. When you see a quadratic function, you look at that leading that first number you see here, which later we'll call it the leading coefficient. That number you see, a. If a is a positive number, then the graph, the parabola, has to have that kind of shape. It's like a happy one. If a is a negative number, the parabola, the graph, has to have that shape. It's a sad parabola. On every parabola that you graph, you're going to find a really, really, really important point. On a happy parabola, it's this point right here. On a sad parabola, it would be this point right here. Now that point has a name. Let's just write the name between here. It's called the vertex. Notice on a happy parabola, the vertex is going to be the smallest y value of any point that's on the graph of the parabola. So you could kind of think that on a happy parabola, the vertex gives a minimum, whereas on a sad parabola, the vertex, that y-coordinate, it's like the largest of any y-coordinate. It's going to give a maximum. Alright, so we now know the graph of a quadratic function is called a parabola. We know if a is greater than 0, it's a happy parabola. A is less than 0, it's a negative number, it's a sad parabola. We've identified the really, really important point called the vertex, and that on a happy parabola it's a minimum, on a sad parabola it's a maximum. What I'm gonna write down next is how do we locate this vertex? It's a really important point on a parabola. So you know what? I think I have enough room right over here to find the vertex. So let me just kind of get this tossed in right here. It's probably the most important point on a parabola. Well, here's a handy-dandy little formula to tell you the x-coordinate of a vertex. It's negative b over 2a. So whatever b is, whatever number that is, toss it in here. Whatever number a is, toss it in here. And then negative b over 2a it'll give you the x-coordinate of the vertex. But you'll need to determine the y-coordinate of the vertex as well. In order to get the y-coordinate of the vertex, you take whatever this ends up being, whatever number it ends up being, and you toss it back into the function for x. You're evaluating the function, and that will tell you the y-coordinate of the vertex. And let me just kind of break this off right here. And I just wanted to list a couple of facts about parabolas and quadratic functions. So here's the first fact. Every quadratic function has a domain of all real numbers. That's a fact. The range, I'm not going to write this down, I'm going to verbalize it. The range depends on if you have a happy parabola or a sad parabola. And the key in helping you with the range is going to be the vertex, the y-coordinate of the vertex. So if you have a happy parabola, the range is going to be whatever the y-coordinate of that vertex is to infinity. If you have a sad parabola, the range is going to be negative infinity up to the y-coordinate of that vertex. So for a happy parabola, the range is y-coordinate of the vertex to infinity. Sad parabola, it's negative infinity to the y-coordinate of the vertex. So the y-coordinate of the vertex is key in helping us find the range for these quadratic functions. And one final comment, because the next thing we're going to do is we're going to actually graph and label all these important points, is remember when you're trying to find x-intercepts of any graph, of anything, any kind of function or equation that you're going to graph, to find the x-intercepts you let y equal 0. And then if I ask where you need to find the y-intercepts, you're going to let x equal 0. So that's old information. I'm not writing it up there on the board. But I think what we need to do next is actually look at an example of graphing a quadratic function and labeling all the important points, which will be the vertex, the x-intercepts, and the y-intercept. Maybe classify the vertex as being a maximum or a minimum. Maybe we'll even, find the range. But let me erase the board, and when we come back, we'll do an example. All right, hey folks, here we are. We're going to look at this example. Have up here, let's consider the function x squared minus 6x plus 8. That's a quadratic function. We know the graph is going to be a parabola because the graph of quadratic functions are parabolas. And I thought we'd try to do a lot of stuff with this one example, just embed everything into one example. So I said, let's find the vertex. Let's find the x-intercepts. Let's find the y-intercept. Let's determine the domain, the range, and let's sketch the graph. So we're going to do a lot here. We're going to try to get a lot of mileage out of this one example. And I'm not necessarily going to do everything in order here because it's a quadratic function. Every quadratic function, I should be able to answer this question pretty quickly. What's the domain? Well, the domain is all real numbers. I'll be able to get the range once I know what the vertex is. So I'm coming back to the vertex. I think the vertex is the most important point on the graph of a parabola. So let's find the vertex now. Remember that little formula that I just written up here a minute ago. The vertex, the x-coordinate of the vertex is negative b over 2a. So we get the x-coordinate of the vertex to be negative b. Well, b is negative 6, so the opposite of negative 6 is positive 6. A is 1, so 2 times 1 is 2. So we get the x-coordinate of the vertex to be 3. So right now we know the vertex is at the point 3, and we need to get the y value. Okay. To get the y value, the y-coordinate of the vertex, you simply have to evaluate your function at what this x value is. That is, all we have to do is evaluate f of 3. And you know how to evaluate functions. You're going to put 3 in for the x's. So that gives you a 3 squared minus a 6 times 3 plus 8. So that's a 9 minus 18 plus 8. Let's see, 9 minus 18 is negative 9. Negative 9 plus 8 is negative 1. So we have found the vertex. We found the coordinates of the vertex. And we're going to go a step further. I didn't have it up here in the directions, but I'm going to mention it now. Is this vertex going to be a maximum or a minimum? Well, A has a value of 1. A is positive. Because A is positive, we know our parabola is going to have this shape. We know we're going to have a happy parabola. And because we know we have a happy parabola, that means that vertex is at the bottom of the graph. It's a minimum value. Let's find the x-intercepts next. Remember, to find the x-intercepts, you let y equal 0. So we toss 0 in for f of x, and we have to solve that equation. I hope it factors, because if it doesn't factor, I'm going to have to probably head off and think about the quadratic formula. We're going to be seeing that coming up, not right now. I think this factors to x minus 4 and x minus 2, which tells me, I set each factor equal to 0 and then solve. So I have x minus 4 equals 0. That will give me x is 4. X minus 2 equals 0 gives me x is 2. So the x-intercepts are at 4, 0 and 2, 0. Y-intercept, I have that up here. Find the y-intercept. Remember, to find the y-intercept, I'm going to squeeze that in right here. To find the y-intercept, you let x equal 0. So you toss 0 in for the x's. 0 squared is 0. 6 times 0 is 0. 0 minus 0, 0. 0 plus 8 gives you an 8. So the y-intercept is at 0, 8. So progress check. We found the vertex. We found the x-intercepts. We find the y-intercept. We should have enough to sketch the graph. Let me get the graph right here. And, let's see. Get some tick marks up here. I'm going to scale my, excuse me, I'm going to scale my x-axis and y-axis by 2's. So here we are. Let's plot the vertex. 3, negative 1. So 3, negative 1. Well, if that's 2, that's 4. 3's in the middle. So the vertex of 3, negative 1 is about right there. We draw a little leader line off of this to label it. That's 3, negative 1. That is the vertex. X-intercepts at 4, 0 and 2, 0. So x-intercept at 2, 0. X-intercept at 4, 0. Y-intercepts at 0, 8. So 0, 8. I think that's enough to draw the graph because remember, A is 1. A is greater than 0. It's a happy parabola. So I should be able to sketch something that looks like this. There's my vertex. Make it nice and big. And let's answer the final question that I haven't answered yet. What's the range? Well, notice how the range goes from negative 1, the y-coordinate of the vertex, to infinity. So I'll write that in here finally. The range is negative 1 to infinity. So the vertex helped us there. All right, so that's that's an example. We did a lot of stuff here in this one example, but hopefully this is making sense and you're saying, hey, quadratic functions and their graphs are pretty easy. Keep in mind, vertex is going to be the key, and knowing if your parabola is happy or sad, that takes you a long, long ways in doing everything you wanted to know about quadratic functions that come in this form. Next up, we're going to look at the second form, or what a lot of people or a lot of books would call the standard form. But we'll look at that when we come back here in a minute. Alright, hey folks, at the beginning of this video I talked about that there were two different type forms that quadratic functions could come in. The first form that I showed you was f of x equals ax squared plus bx plus c, and I consider that to be that's like the real deal form. That's like the definitional form. What some people, or a lot of people, and a lot of books call the standard form would look like this. F of x equals a, still a real number, times the quantity x minus h, that quantity squared, plus k. So a, h, and k, they're real numbers. A does not equal 0. The only benefit of seeing a quadratic function in this form is that if it's in this form, you can immediately read the coordinates of the vertex. The vertex will be at hk. hk. That's a huge benefit of having your quadratic function in this standard form. And then everything else is still the same that we've discussed so far with quadratic functions. That is, if a is a positive number, the graph is going to be a happy parabola. The vertex would be a minimum. If a is a negative number, the graph is a sad parabola. The vertex would be a maximum. So everything is still the same. What I'd like to do right now is I'd just like to compare and contrast these two forms. And it's if you are given a quadratic function in the form ax squared plus bx plus c versus, and I'm going to have to erase over here because I want to make a comparison. So hopefully you have this under control. You have it either written down. If you don't, you need to make some notes. I would suggest you do that right now. Pause the video and take some notes on this. Write it down because I'm going to erase it. So it's this form versus the standard form. And I'm going to list a couple of examples below each. So in this form, let's say you saw the function x squared minus 4x plus 7. And over here it was given to you as x minus 2 quantity squared plus 3. Okay. Folks, if I am given the quadratic function in this form, here's what's going on in my head. Here's what I'm processing. A is positive. The graph is a happy parabola. Let's find the vertex. And to get the vertex, I would use the little formula, negative b over 2a, for my x-coordinate. So that would give me opposite of negative 4. And a is 1. So I would have the x-coordinate is 2. And then how do I get the y-coordinate of the vertex? That's right. I evaluate the function at 2. So I put 2 back in for the x's and I get a 2 squared minus a 4 times 2 plus 7. So that's a 4 minus 8 plus 7. 4 minus 8 is negative 4. Negative 4 plus 7 is 3. So I get the vertex to be the point 2, 3. And then I try to find X-intercepts and find the Y-intercept, plot the points, and I know what the graph looks like. If I'm given the quadratic function in this standard form, where it looks like this, I kind of start off with the same mindset. A is a 1. That's a positive number. So I know the graph of this is going to be a happy parabola. But I want to find the vertex. Such an important point. We should always think of finding it first. So I find the vertex, and because it's in the standard form, I can immediately read the vertex as h is 2, k is 3. So I can immediately read the vertex as 2, 3. I would not take this x squared minus 4x plus 7 and go through the process of completing the square to put it in this form so that I could then read the vertex. I have a method. I know how to get the vertex when it comes in this form. I know the formula for the x-coordinate of the vertex. So I just wanted to compare and contrast the two forms. Again, benefit of this form, you immediately can read the vertex. This form, you have to use a little formula to get the x-coordinate of the vertex. We're going to come back, we're going to do one example of turning it around just a little bit. Alright, hey folks, here in this last example, what I thought we'd do is I start off, I'm giving you the graph of a function. I'm going to say this is the graph of a quadratic function. And what I've labeled is the y-intercept is here at 0, 2. The vertex is at 3, 0. And because I know the vertex, the first question I'm asking here, part A, is use the vertex to write that parabola, to write it in the form f of x equals a x minus h quantity squared plus k. So I can see over here, remember vertex, I can see this is h, that is k. H is 3, k is 0. So I put a 3 in here for h, I put a 0 in for k, and I get f of x equals a times x minus 3 quantity squared plus 0. That's just using the vertex, tossing in a 3 for h and a 0 for k. You know, if you like, and I think it looks a little cleaner, a little crisper, why not just write that as a times x minus 3 quantity squared? I mean, that looks a little cleaner, don't you think? Part B, I'm saying we should be able to use the coordinates of the y-intercept to determine the value of A. Now, to use, I said the y-intercept is 0, 2. So let's think about this. The y-intercept is 0, 2. That means when 0 comes in here for x, 2 has to come out for y. So I have f of x equals a times x minus 3 quantity squared. I know the y-intercept is 0, 2. There it is. So when I put 0 in for the x's, so here's 0 going in for the x, what comes out for y has to be 2. What comes out for y, what comes out for f of x, has to be 2. I should be able to solve this for a. I mean, we know 0 minus 3 is negative 3. Negative 3 squared is, negative 3 squared is 9. So we have 2 equals a times 9. Divide both sides by 9. You get 2/9 is equal to a. I just found the value of a. So what I think I'm going to do in part C, and I'm going to erase the graph now so I can do part C. What I'm going to do in part C is, since I know the value of A, I can write the function in the form ax squared plus bx plus c. I can write it in that form. So now how am I going to go about doing that? Well, look, in part A, the vertex told me it was f of x equals a times x minus 3 quantity squared. In part B, we found the value of a to be 2/9. So I can go ahead and put the 2/9 in here for a, and that gives me that the function, putting 2/9 in for a, it looks like that. So what we have to do now, let's see, we have to just do a little bit of some multiplying. We need to put down this step. We need to take x minus 3 and square that. So we need to do x minus 3 times x minus 3. That will give us an x squared minus a 6x plus 9. Next step, distribute the 2/9. Okay, I'm not too happy about that because I hate fractions. But we get a 2/9 x squared. When 2/9 gets multiplied by 6, that's going to leave us with 4/3. When 2/9 gets distributed to the 9, well, that's not too bad. That leaves us with the plus 2. And we have the quadratic in the form ax squared plus bx plus c. So notice this would be called the standard form. Once we found the value of a and we tossed it into here, we got the standard form. Then we did the algebra, x minus 3 times x minus 3 to give us this, distribute the 2/9, and we brought it to this form. So that's kind of where I thought we would stop here with this introductory look at quadratic functions. Hopefully this is making sense. Let me just stress one more time. Important point is the vertex. If it's a sad parabola, the vertex is a maximum. If it's a happy parabola, the vertex is a minimum. You're going to start to see the importance of that probably in the next video when we take a look at some applications of quadratic functions. But that's it for this video. Hope it's making sense. Thanks for watching.